Valentine, and today I will take you through the top three big O notations with some few Python example. First off, what is big O notation? Big O notation talks about how the runtime of an algorithm increase as the input size increase. It talks about the speed and time it takes for an algorithm to complete a specific task, and help us compare the efficiency of different solutions. What big O notation is all about? It talks about, okay, the amount of time or the amount of speed an algorithm will take to finish a specific task. Why do we use big O? O stands for growth, and big O gives us an upward of the worst case in a growth system. The most three common types of big O notations is the constant, the logarithm. The most common big O notation are the constant, the logarithmic, and the linear. Now, let's talk about the constant time. Now, here, time remain constant no matter the input size. Now, let's take an instance of an array. If we have an array, probably we have an array of like coming, probably we have 2, 3, 4. I know in an array, the first elements in an array has an index of 0. So now, when finding the first element in an array, we will always know that it has an index 0. So we can easily just call it like your array index 0. This is going to always give us the first element in an array. Okay, or for instance, if you have a textbook of like 100 pages, and we're asked to find page 10, we always know that we are going to count 10 pages of the book to learn the page 10. And that's the same thing if you are to get the page 10 of a book of 1000 pages. We always know that we have to first count the first 10 pages. If I have to get the page 10 of a book of 1 million pages, we also need to count the first 10 pages. So that's how constant time is. The time remains constant no matter the input size. So even if the input size grows really, really, really large, the time always remains constant. It has a constant of 1. It remains constant always. O notation. That's the O1 in Python. Let's say we have an array of let's say here first first numbers. First numbers, once find the first numbers in this array. First number in this array. First number is 2, 4, 6, 8, 12. Let's just print as let's say print the first number in the array is first number. Now let's print it as Python constant. Right. Now you see the first element in the array is 2. Now why do you think the first element in the array is 2? In Python, array has an index 0. In Python, array starts from an index 0. So now that means that this here is going to be 0, 1, 2, 3, 4, 5. So now we know that this element, this array that is now, it contains how many elements? 6 elements. All of them has an index of what? Altogether is going to be 5, because the elements in the array starts from an index 0, which is now going to what? 5. So now to print the first elements in the array, first number in the array, it has to start from -0, which is 2. And this is what's called about constant. You can you can take in, or you can just check the number of index you want in an array. That's why it's constant. It's very easy, it's fast. It's just for you to input the index of the array you want and you get the number. Let's check an index theory. Index theory, for example. Index theory. Now, index theory is not the first element in an array. It's hidden the index. Let's see the index number. Okay, the index of the fourth number is item constant py. Category is 8. Let's check if it's correct. Is 0, 1, 2, 3. Index 3 is 8. It print out 8 here. Now this is the same thing. That's why it's called constant. It's fast. Just for you to input the number of index you want and you get the number. That's the same thing that goes with the textbooks and yeah. Constants are really fast.